All right.
This call is now being recorded.
Thank you.
That was weird.
I don't know
All
why
right.
everybody keeps doing that.
Super echoey. Cool. Okay. So what I want to try to do, I'll see how far we get, but I'm hopeful. The first thing that I want to talk about, oh, and I started to put videos in here, so there's some videos for the first section. I'll wrap that up today or tomorrow. What I want to talk about today is this thing called a hash table. Hash tables are how we can, we use hash tables for two things. Let me hear you echo. Hash tables are used because they are insanely fast compared to other kind of data structures because we don't need to search for them. We just do some math and then we get the data we're looking for. So that's why we do hash tables, is because they're a lot faster. We can also use hashing functions to store data securely. It's not the same thing as encryption, but we can use it for a little bit more security. So the way we need to do some drawing. I don't know does this do anything if I turn this light on? Does this do literally anything? No. No? Okay. How about that? Is that better? Yeah. Okay. Yeah. I have a light in here, like an actual ceiling fixture light, but like I'm pretty sure it's like one LED bulb and that's it. Okay. So, also, the cat has decided that she hates the dry erase eraser. So, might have to buy Chase a new wood. So while I'm erasing this, can somebody explain, like, in math terms, what a function is? So, like, not from a programming standpoint, but from a math standpoint. What's a function?
A function is y equals mx plus b. It's a slope.
So that is a function. But what are, like, functions in general?
Functions is a input that has one output.
Exactly. Yep. Butanist. So this idea of one output is really, really important. Oh, look, my disk is full. Oop. I'll fix that later. It's all the recordings. So is this high? Can you guys see this? So ZZ was specifically describing a one-to-one function. So in general, a function is just like almost what we do in programming. It's a set of instructions that we're going to do. So something we do to input to.
Alrighty then.
Oops. I have a glass jar of markers and I just knocked the whole thing down.
Oh no.
I don't think the glass broke, so we good. To get output. So, okay, you know, addition is a function. You know, subtraction, slope, whatever. Those are all functions. We do also have those one-to-one functions. Oops. And these mean that each input will only have exactly one output. So let's think about this for a second. Why would we care about how many outputs a function would have when we're thinking about storing data? Can we think about why this would matter?
could matter if you're doing a login service. So like one username should only have one output for the password.
Mm-hmm. So another thing is when we're doing data storage is if two inputs lead to the same output, where is it going to go? So let's think about it. If our function is, y, oopsies, equals x squared, the data of -2, because -2 squared is 4, but the data of 2 is also 4. So which one am I going to store here in this position? I don't know. Bad time. So this is why we really care about this one-to-one. We want to find a function that is one-to-one for all of our stuff so that way we don't have this. This is what we call a collision. So let's talk about what this structure looks like. So this is a table, shockingly. A hash table is a table. And I'm going to just put it in half. And this is a representation of our physical memory. All of the stuff that we've been talking about for the past week has been representations of physical memory. And so this is our position. And here's our actual data that we're storing. Obviously, like we would be storing other pieces of information too, like strings or links or whatever. But just for right now, we're going to do just numbers, so it's a little bit easier to visualize. So our position starts at 0. And then we'd have a bunch of memory positions, but that's what we have right now. So what we do to get our data, so here's our beautiful data. There's a bunch of stuff hanging out in our data over here. We want to get it into our table. So what we're going to do to get our unorganized data into our hash table, this is also called an associative array. And what this means is each piece of data is associated to a position. And it just makes it so much easier to sort because we know exactly where it's supposed to be. This. So this will be we consume the data later. So what we do for this is we do a hash function. And a function is just a set of math to get an output. So what we're going to do for our first one is we're just going to say, okay, you know what? +1. That's all we're going to do. Super simple function. So then let's say I have 1, 2, 4. So then I take my data and I run it through my function. Ooh, that's loud.
Yeah, sorry.
So 1 + 1 is 2, so we put 1 here. 2 + 1 is 3. We put 2 here. And then, I don't know, that's 5. So we can be like, Great. Cool. So far, so good. And this would probably be fine. Like, adding 1 to this is probably a one-to-one function. For what? What do you wait, what me? How did you get 1 for the output of 2? Because so this is our data, and this is our data, and we applied our hash function to our data. So 1 + 1 is 2. So that tells us to store the data 1 at position 2. We're going to do more hash functions too, so hopefully it'll sink in a little bit more. And then like this one would be 5, and so he's like, yeah, here's somewhere. Great. So that's one hash function that would work, and +1's probably fine. Like we're never going to get, there's no two numbers you can add 1 to that you get the same thing, Like 0 plus 1 is 1, -1 plus 0 is 0. Great. Let's try a different hash function. I'm going to change my data to. Let's square them. So we're going to say our hash function is squaring them. So 1 squared is 1. Cool. 2 squared is 4, so that'd go down here somewhere. But what's 0 squared? Is it 0? Yes. Okay, so that's fine. What if I have -1? -1 squared is 1. Now what do I do? So this is what we call a collision. These two have crashed and our hash function is no longer one-to-one, and so we have had a collision. So we need to do collision resolution. Yes, you explode. This is bad. This is not good. Bad news there. Not great. It's not a good time. So what we have to do instead is we have to write a collision function. So in this case, we can just be like, +1. And then we can put our -1 in here. Great. So these hash functions are used for storing data in an associative array because it's really fast to go backwards. Oh, poor baby. What a cute puppy. That's cute. So we care about this because, like, if I want -1, I can just go to this position and get it. And then if we have a really complicated hash function, we just reverse the hash function. And this is why this is not encryption. So remember, encryption is really easy the one way, but really hard the other way. Hashing is pretty much the same either way. This is used for storing stuff quickly in associative arrays and can provide a little bit of a layer of security. It's not the end-all be-all. We'll talk about salted hash functions later, but this is not encryption by itself. If you want to do encryption with this, then you need to do another step. So hash functions are used because they make really fast associative arrays, and they're pretty easy to get the data back out quickly. And they're really easy, not reversing, we just add another function to it. Reversing it is how we get stuff out, to get our stuff back out. We write a collision function. Collision? And this is just another function that we do to our data in order to resolve a crash. This can literally be like, just do it again, which sometimes doesn't work because, like, if I just ask it to do it again, what does it do? You know, one squared is still 1. So this one right here is not a good collision function. But, you know, adding 1 can be a good collision function to just move it down. Consume. Exactly. Yeah. So sometimes you can just repeat the original function as your collision function, but a lot of times you might need to change it. Cool. So this is like an introduction to this. It's not the end-all be-all. I just want you to be introduced to the concept of hash. We do use this for like storing passwords and stuff. I don't know if I will go over this keyword this week, but if I don't, let me just go ahead and say it. We also use this word salt. Salt, a salted hashed password, which sounds really tasty, it means that you have put extra information in before you ran it through the function. this idea of salting means that you are going to kind of throw off everything else, because then if you just try to apply the hash function without any other information, you won't be able to go backwards. So we use salt for password encryption, and you should, like, if you're hashing your functions, you should probably salt them. And so this little piece is just adding extra information. So we'd be like, okay, you know what? Our salt is going to be +6. And so then if you don't have the salt, I'll draw a little salt shaker. There we go. There's your salt shaker. I hope you guys enjoyed my artistic genius. So here's our salt. And then if you don't have the salt down here, you won't really be able to resolve what it is. It'll be a lot harder to figure out what's going on. I think I'll talk about this more in depth this week, but if I don't, I did want to just give you a definition for this word so you have it. It's not like critical, but I want you to have this definition. Okay, so that is what a hash table is for. We use it for storing data that we don't want to just like store just plain. And we use it because this kind of data structure is very fast. Because like we don't really have to worry about like the runtime of reading through an entire table. It will only be the runtime of this function, which is going to be like 1. Because you are only ever doing one piece of input and one output. So the runtime for this is very fast. So any questions about conceptually what this is? Cool. You won't use this like as a math piece a lot, but you will use hash functions to like get passwords and that kind of stuff out of a database. Yes. What is your questione? Oh. Yes. I used to eat a lot of how is this how passwords are stored generally? Yes. So you will do a salted hashed encryption function. And then that will store the encrypted password here. So your function would have some sort of encryption in here too. So right now, like squaring the number is not really encryption because it's really easy to unencrypt. I don't know an encryption algorithm off the top of my head, homie. So like we would do something like let's check some, yeah. I'm gonna put this MD5 is old. These are all really old. But yeah, so this is old. So it's like LastPass encrypting my password bank with another password not used in the bank. Exactly. Exactly. Yes, that is exactly it. There is some piece of information that the end output will not know, and that's what we use to set the math with. Exactly. So this is old. We don't use SHA-1 anymore. I think we're on SHA-3, and we're not on MD5. These are all deprecated, but you just applied that function. So if we were going to do encryption here, we would be like, we would run our SHA function, and I think we're on 3. I could be wrong. To our data, and we would also add something to it. So we'd add our salt. So that's what are you doing? Are you just whining? So that is what we would do to actually save it, is you just run that encryption thing that's given to you by MySQL. And you can just call that from Node and all that too. What this actual function does, I don't know. But then if someone got access to your database, that's what it would look like. And then there's an unencrypt thing that you can call to get it back out. Okay, look, that one said there was something about the deprecations. Let's take a look. SHA-512. Ooh, I'm all sorts out of it. This is with PHP, but yeah. So you call in your JavaScript or Node, whatever you're doing, something like this. This is for PHP specifically, but it's pretty similar for Node. You use the bcrypt. You use this module and then run it. So yeah, I'll put this in Slack for y'all. Excellent. Okay, so good questions. But yes, this is typically how we would do it. So this is 512 now. I think the SHA whole thing is deprecated, actually, off of the top of my head. Ooh, don't start. I'm gonna sleep. About that dude. Yep. Minus 13 lines of code. But yeah, so we give it our data, we give it our salt, and then we get our new stuff. Any other questions about hash tables? How do we code them in? You use the function from another external source. You don't typically write your own encryption modules. So in Node, we use bcrypt. In PHP, we use crypt. So you just use a module. And so like when we're writing like a SQL query, we would wrap the password in a function like that.
I have a question. You probably already covered this. I got away with my time. Did you show? I see what a hash table is, but can you show what it looks like? Like in code, is there a way that is it just a table in your code that you? Is that it? Just create a table
to show.
Oh, you got a link there. Okay.
Yeah.
Chat table. Okay.
Note on complexity. Blah 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 blah. I don't have one built because I normally just smoosh it to. The only time I really use it is for like.
Okay.
Stuff in a database, so I don't have like what it looks like. So, or flip through this and read it if you're interested on more of how it uses.
Okay.
this because I don't typically use it to store data that's not going to a database. And then I think this also this kind of stuff gets into like if you are interested in doing like the hacking level of this is what you want to start going down this data structure road because you can get really cool stuff going on.
Alrighty. All right.
The other thing that I do want to say about this too is this I'm going to briefly talk about rainbow tables. Yes, rainbow tables. And then we'll keep on keeping on. Rainbow tables. All right. Oh, we're on Twitter now. Excellent. So what this is a rainbow table is like basically like how long it's going to take to get things to just be broken. So the blue ones are negligible, like they don't matter. These are all different kinds of encryption modules. So 7-zip encryption is like what you use to compress like when you download stuff. The SHA-512 and SHA-1 and SHA-256 are different implementations of the SHA encryption. And then we got MD5 is used a lot for like making sure something's correct. Let's see what else. These are the Unix one. I don't know what these AES encryptions are. I don't know what Blowfish is. What do the colors mean? The colors mean how long it takes to, right? I want to zoom in. Yes, there we go. The colors are how long. Let me scoot. That's annoying. The colors are how long it takes to do it. Yeah, the blue is instant. So they're negligible, like it's not hard to break. So like the 7-zip, like it doesn't become, it doesn't become a big deal until like you're into like, it has to take like 9 to take it. What we can see though is some kinds of encryption take a lot longer, much quicker. So like the Bitcoin encryption starts to get hard to encrypt pretty quickly. We can see that also for like this Unix implementation takes a long time. Yeah, that's the Unix one is the longest, the fastest. And what this is saying is the bigger the search space, the longer it takes for something to break the hash and figure out what the password is. When you have broken something with a rainbow table, you have like broken the whole thing and you can just get all the pieces of information. So like some of these things, not great. This first column is how long it takes, like the speed of the encryption and decryption. Notice though that no matter what it is, so like this is instant for a while, once you get to a big enough search space, it's still really long. But one thing that is important, I think also the black squares are just not tested, I think, is what the black squares are. What's really interesting though is even when your search space is really big, it doesn't matter if you've picked a weak encryption, it still is like a crazy amount of time. Because this is 1.1 million years. That's how long that is. And so that's why we also like to make search spaces big, is because it really, really bumps up the time it takes. One thing though is notice none of these are never. Like, this is like a crazy amount of time, but that's not Never. There is no completely secure function. Especially like with quantum computers too, it's much different now, and these numbers are probably much lower. Because this is from what? How old is this? Yeah, this is from last year. No, I don't want to install the app. I just want to reset the Zoom. Yeah. And so this is from last year. But yeah, so this is a rainbow table. Pretty fancy. Cute. The black, I think, were ones that it hadn't tested yet. But yeah, I think it didn't have like a great one, but I think that's what it is. But yeah, so lots of fun. It's a rainbow. Yes. Yep, yep, yep. Cool. So it's a little bit of a derail, just talk about like, this is what we use. We use some kind of standardized encryption formula, and we hash it and salt it. And that's, the salt also helps us not get a direct break because it's a little bit harder to do. That being said, at this current point, there's no such thing as perfect security, unless like you unplug your computer from the internet. Put your laptop in a Faraday cage. Case it in carbonite. Then you just hack the person who owns the computer. Exactly, yeah. You just encase your laptop in concrete. Exactly. So yeah, that's a little bit getting into cybersecurity. We'll talk more about it this week, I hope. But yeah. All right. So I think we can make a pretty good dent into algorithms, unless you guys have more questions about hash tables. Hebs. Okay. If you are interested in like cybersecurity stuff, data structures are a really great path to go down to get more about this kind of stuff. This also, again, like an algebra refresher course would probably also help with this piece too. Okay, moving on. So we've spent like 3 days talking about different ways to store data. Wow. So we want to use it, right? So we use data, we store data because we want to use it, and that means that we have to search theoretically. Yes. Theoretically was one of those words that I used way too much when I was in high school, like so much so that that's like something my mom will still pick on me for because I would say theoretically all the time. It was my jackass way of being like, maybe. Like, you know, are you going to do your chores? Theoretically. I've always been a jackass, y'all. It's very sad. Theoretically, they're not done yet. Exactly. Do cloud services do this automatically? That's a really good question. And no, if you are doing like, if you're hosting a database, and I grew maybe misunderstood it. Yeah. Yep. I was annoying. I would still do the chores, but you know, I'm annoying and it's okay. Most cloud services will not do this automatically. Like if you just got a database hanging out on the cloud, it will not just do it by itself. You will have to set up an implementation of a hashing function. I don't know. I did it a lot was the issue. I did not do it occasionally. I did it a lot. Like I probably said it like a dozen times a day at least. It's like my like. If you are, yes, it was a joke. Yep, for sure. If you are using a pre-done service, a hash function might be built into the setup. Theoretically. Like, I say like a lot too. That's definitely my other speech filler. I don't say a lot, but I say like, and you know. They're like, yeah, like, you know, like, totally. Yes, like, I say like all the time. I don't do ums or ahs a lot, but I say like a lot. I do say yay. That's not a speech filler per se, though. I don't know what that is. I grew up in Northern California, though, so I was doomed. We'll have a cultural exchange. Excellent. Okay. So given a data set, we want to figure out how computers search through things. I'm going to teach you guys 2 search algorithms. I do yep. Yes, that's Ducky from Land of Time is probably where I got it because I watched Land of Time a lot when I was a little kid. So the yep is probably from Ducky. So yep. Yes, the voice actor story is very sad. We'll take that one, like if somebody wants to like put an article in Slack, because it gets dark real quick, like real dark real quick. Yes, and if you are sensitive to like violence toward children, I recommend just like not getting into it at all. Because I know like, yeah. That blue skidoo? Yes. Yep. Yeah, it's, if you want to go read about it, go ahead, but like be warned, because like I know like some people with kids like get like really like that makes them like sick to their stomach, and so like, you know, I'm gonna content warning if you want to look at it. It gets dark really fast, but I don't want to like, you know. Yeah. Exactly. The nope. Yeah. Yes, because like she was really young. So if you want to know, yes. If you do not want to know, or you are sensitive to that kind of stuff, you know. Yes, but like if you do want to know, you can look at Wikipedia. Otherwise, theoretically, yeah. Yeah, I just, you know, some things are kind of like, I like crime podcasts and all that, but like there's something about when it's kids that it just makes like achy feeling, you know. And since I know a lot of y'all have kids, especially younger kids, I'm definitely going to content warning y'all there, because that's some dark things. Cool. Okay, so we're going to move on. If you feel like looking at it and talking about it, cool. But make sure to do it in like a private thing. Yeah, everything freaks you out now when you have kids. Yeah, that's what Mom always told me, is like she didn't really care about stuff until she had me. Yes, it is. Yeah. Yeah, if you guys want to talk about it, like, cool. I just don't want to make anybody who doesn't want to talk about it have to know about it. So feel free to Slack each other about it. Just make sure you're not slacking anybody who doesn't want to talk about it. Yes, exactly. Yeah. Especially little ones. All right. So let's keep on keeping on. The first thing, yes, like Haley about it. Oh, I'm just kidding. Yeah, All Dogs Go to Heaven is one of those movies that would make me like super, super sad as a little kid, and I'm sure if I watched it now, I would just cry. Like Oliver and Company and like The Great Mouse Rescue, like all of those would probably make me cry now if I watch them again. Yeah, yep. All of those movies, they would for sure make me cry. I'm a softie though, I cry all the time. Yes, for sure. So let's say, I'm gonna make just a list of stuff. Okay. So, yep. Dead Space the game, or are you talking about Event Horizon? Because I've seen Event Horizon. I do more too now, yeah. I do feel like the older I get, the more easily I cry. For sure. The game. No, I haven't played Dead Space. I watched other people play it, but I haven't played through it. But it's on my list. I do like horror games a lot. Oh, goodbye, pen cap. Alright, so we got a list. We can add some other stuff too. We can add, spooky movie, because it's Halloween now. Spooky movies. Great. We're at like our local Target. Dead Space is super scary, yes. That's why I've never played through it. The like scariest game I've ever played was Left 4 Dead. Everything else is too scary for me. So we have this list of things at our local, Target. It's easy. Chill. Give me like 10 minutes of attention and then we can get into video games. It's okay. I get easily distracted and it's my fault too. So we have our list of things at our local store. Serious mode. Activate. And what we do is if we're going to do a linear search, we are literally just going to look at every single item and see if it's what we're looking for. So if it's apples, great. It's all the way at the top of our list and we're done. But if it's spooky movies, we literally have to check every single thing until we get to where we are. So that's what a linear search is. What does a linear search look like in code? Can somebody tell me like what this would look like? Because you've already done stuff like this a lot.
Oh, like when you iterate through each item? Like a for loop?
Exactly. Perfect. Yep. Mm-hmm. So these are super easy to implement. They're for loops. They're while loops. They are super, super easy to implement through. But they're super easy to implement, which is really nice. And if you are, and it will always give you a correct answer. This search algorithm always works, like, again, if the piece of information we're not looking for isn't in the list, it won't work. But it's cool. It just works. The other thing that's really nice is other searches, we have to do work to our stuff before we get to actually use a search algorithm. Linear search doesn't care. We can put these in whatever order we want and it will just work. So that's what a linear search looks like. Any questions about linear search? Cool.
No, I think that's the simplest thing we've talked about today.
Yes, for sure. So let's do a really quick implementation ever. Yeah, this is the easiest thing ever. Okay, let's do a really quick code implementation of this and then we will wrap up today. We'll do some a little bit more complicated tomorrow. Oh, homework. That's a good question. Yes. Yep, it is already almost 4. Today went zoom. Go register. That is it. Yep. Yep. It's been so long we have homework. Yep, you guys haven't had homework in a minute. That is a very good point. I think you're right, Christina. I think that's all we're gonna do. Yeah. Yes. Okay. So yeah, that's actually a really good point, Christina. We're gonna be doing APIs this week. We might not do part 2 yet. Yes. That's weird. Okay. I got used to no homework. Yes. Okay. Yes. So we'll talk about APIs later this week. We haven't talked about how to do this yet. But it takes a couple hours to get your API registered. So please just register your API keys and make a GitHub repo. So today's homework is this. I want you to do week 11, homework 1.
Is it the current weather data? Because I see you can filter that by location, so to make sure you get the right one, because there's like a ton.
You want to just register. I think all of them will give you the same API key. Yeah,
Gotcha.
so these are 2 separate pieces. Make a new repo for week 11. Make it a node project. So do your npm init, make a readme, all that. Separately, make an open weather account so you get an API key. And let me show you what that looks like. Boop. Oops. Go away. Log in. I don't know what password this is. Go. Cool. So then when you log in, you'll get keys. And then, yes. Can we use any open weather account? Yeah, the account is separate from everything else. So it doesn't matter. You just make an account, and then like all of those picking the different APIs are different. So you just make one account, and then you can go through all of the other stuff. And that's all I want you to do tonight is make your API stuff, because this takes a couple hours to generate. Just so that way you have it for make an account, make a node, then make an API account. Exactly. Yep. That is your homework arena. And Slack me if you have any questions. I don't want you to do anything with it yet. We're just doing setup because this takes so long. We're a teensy bit behind, but we can do this at least and get it all set up. Cool. Thank you, Haley and Christina, for guiding me down the path of not setting y'all up for failure. All right. Because, otherwise I'd be like, okay, do 6 homeworks all at once. Go, go, go. Cool. So real fast, let me show you. I'm asleep. Yeah, I don't blame you. Whatever, this means I have to grade homework again. Oh. All right, let's see if I can do this in 3 minutes. I believe in myself. I don't believe in my computer, though. Serious mode. I can't even spell lemons right, y'all. All right, what other fruits we got? We got apples.
Oranges.
Oranges. Okay.
Bananas.
Oranges. That'll do.
Yes. Okay.
Zero. Whoops. Less than fruits. That length. If fruits. Oops. What am I missing, y'all?
Your iteration, I++.
And so then we would just put in whatever we're looking for here, apples. And then we could ask it to print out the position for us. Oops. There. We wait for it to save. Open up our console. Oh, wow. Okay. What? Cool. So that's a linear search. It's not hard at all. It is saying, hey, like go through every single thing and then tell me if you find it. And then we could do like maybe, an else, console dot log not in list. I'll put this in Slack for y'all. Cool. Okay. Woo-hoo! Linear search in like 3 minutes.
You did it. Good job.
Thank you. Excellent. Oh, I guess it should be an else. That's that. Okay. So, any questions for today? Everybody know what we're doing for your homework?
Yeah.
All right. Please send me your resumes if you haven't. Let me know if you need help. Remember, you have Donna from Augusta Tech, and you have Sarah. Yes, it'll take a minute. Yes, ask if you need help. Yep. Today shouldn't be too bad. Today should just be set up, so shouldn't be too bad. Other than that, I will see y'all tomorrow.
Bye.
Bye.
Yes, the API is what you are looking for. It will take a little bit to generate. So like when you make your account, it probably won't automatically load. And so you just need to wait for it to show up. And that's why we're doing it separate from the rest of the homework, is because it takes so long.